this one is the original image. So this is the final result of the enhancement algorithm using all the steps, like you are adjusting the DC value or background illumination, then you are modifying the AC coefficients, that means adjusting the contrast, and then the color. So this is the original image, and these are the three results using three different types of functions. Three different functions. Same methods are used, but there are three different functions. Now there are certain problems once again. The problem is that if you look at this image, at certain points there are some blocking artifacts. You may, if you increase it, if you just enlarge this portion, you will find there are blocking artifacts. This happens because there are, in DCT domain, these are all non-overlapping N-cross-8 blocks. So there you are introducing discontinuities during processing, and those discontinuities are different. Now to reduce that blocking artifacts, what you can do, you can restrict your processing to a smaller size of the block, and that you can perform by using, like as I told you, that block composition decomposition operations. By using block composition decomposition operations, you can modify that algorithm. So if you consider that a block needs to be processed with a smaller block. The block size needs to be decomposed and then processed it and then again decomposed. That decision depends upon that how much details is there in the block. So suppose in this case what we did, that we measured the standard deviation of a block. Standard deviation of a block can be easily measured by summing up all the AC coefficients. So if you measure the standard deviation of a block, if it goes beyond certain threshold, then we consider that block is subjected for decomposition. That block should be decomposed, and you perform the operation with smaller block size. So that's what we did, this decomposition operation. Then you apply this algorithm on smaller blocks, and then again perform the block composition. Now all these processes are restricted to the compressor. So nowhere we are going back to a spatial domain, because this block composition decomposition operation can be done directly in the compressor. So if you remove the blocking artifacts, there is some improvement. Of course, again, still some artifacts is invisible, but to some extent you can. It depends till what level you would like to go. Now, because if you are going for more decompositions, you are increasing your computational overhead. So there is a trade-off. So we did it just for one level decomposition. So there are some results of different techniques, like you have the original image, and these are the conventional compressed domain based technique what was reported earlier, and this is the one which is Ayaz and which we got, and this is a technique which is a spatial domain technique, and as you can see, the spatial domain technique is giving the best performance. In fact, you are processing pixel wise, and this is a Retinix based multi-scale Retinix based technique. But it is very much computationally intensive. It takes almost 100 times of this computation. It does a lot of operation. Some of the qualification descriptions that you can learn some of the part, you can check how it is made. Okay. Now, in the compressed domain, there are something, particularly in this enhancement, we considered some of the metrics for evaluating the performance of different things. So far, I have given you all the examples with respect to images, but finally, when you are trying to judge your method, you should also get some kind of objective evaluation metrics. Now, as you see that this is a kind of quality metric, or actually this some kind of structural similarity index that we have used instead of baseline value. This metric is a metric for judging the blocking and blurring artifacts for JPEG images, and this is the contrast or color. This is not colorful contrast, but this is the colorfulness metric. So these three we have used for different techniques, and our technique is this one. This is the latest technique. And these three actually based on our group statements. And based on that, actually, we have chosen this, and all the results are shown with respect to this. This theta group, it stands for a particular mapping function which has been used. So I think and finally, the computation complexity that is expressed in terms of per pixel, how many number of operations you are doing, how many number of multiplications, additions, and also exponential operations. And you can see that these techniques are of course less less expensive. But this is a special domain. What I was referring at is very much expensive. Per pixel, it is so many operations compared to on-these techniques. So this is one advantage to do with the complexity, and of course your quality of result won't be as good as the previous. Now these are some of the variations of these techniques. If you apply these operations over and over again in an iterative loop, then you will find that actually you are enhancing it, and there will be some kind of colors will be finally faded out. Okay? Some kind of desaturation will take place. So this is the original image, and if you perform iteration for this is just one iteration, and this is two iterations. You are really getting I will just quickly review because what I find I don't have much time about this. So let me just quickly go through this color constants process. Already I have mentioned that there are three factors which are required for generation of images or colors also. That is objects present in the scene. That is the reflectance of the surface, reflectance property, spectral energy of light sources, and spectral sensitivity of light sources. And this you can model in terms of how the brightness is produced by considering all these three factors. So these are the three factors. So if you consider that actually you consider these are the same which have been captured by different kinds of illumination, and this is a scene which is captured by another type of illumination. The same scene captured by different illumination will have different types of image.